So I'm going on to doing great and welcome back to my YouTube channel, welcome back to the video, welcome back to the lecture. So I'm back with you guys with another lecture. So if you're new on my YouTube channel, don't forget to like, subscribe, press the bell icon to get a notification of my each and every video. So let's begin with today's video. Anyway, so today we're going to be doing structure of an atom. So we're going to be discussing about scientists and their observation and the creation of laws regarding the structure of an atom. So first of all, the scientist we have is John Dalton, and this is how he looked. This is the real face of John Dalton. This is how he looked. You can search about him. He's very famous scientist, John Dalton. He's a science scientist, and yeah, so he gave the solid sphere model. Okay, the model he gave was solid sphere model in 1803. He gave this model out, and John Dalton's atomic model envisioned atoms as tiny, indivisible, and solid spheres like billiard balls with no internal structure, no nuclear or no nucleus electrons. So this was what he gave out. So he was the one who told us that they were indivisible and they were very tiny. They were envisioned items. Okay, they were solid spheres. Like this was all the things that he told, and he gave an example like they were the billiard balls. Like if they were the billiard balls, he gave the idea like they are solid spheres, they're invisible. That means they were billiard balls with no internal structure. That means they were having no nucleus, and they were having no nucleus and they were having no electrons in them. Okay, he proposed that all matter is made up of these items. Okay, atoms of the same element are identical. Now he told us that atom of the same atom are identical. Atoms of different animals different in mass, properties, and chemical reactions involved items rearranging, combining, and separating. So this was what he gave up. This was what he told. Now key postulates of Dalton's theory: so matter is atomic. All matter is composed of extremely small particles called atoms. So he was the one who told us about atom and what is it. Indivisible and indestructible. Initially, atoms cannot be created or destroyed or subdivided. Element identity. Now atoms of a given element identical in size, mass, and property. Atoms of different element have different properties. He was the one who also told about this, that it vary from element to element. Different elements have different properties and same elements have same or identical properties. Compound formation: atoms of different element combine in simple whole number ratio to form compound. For example, water as 2H ratio 10. So he was the one who told about this as well. Rearrangement in reactions: now chemical reactions involve the separation, combination, or rearrangement of atoms. Significance and modern understanding. How it was significant. Foundation: so Dalton's story provided the first scientist basic basis of for the item, explaining laws like conservation of mass. Refinement: now scientists now know items have subatomic particles, electrons, protons, and neutrons, and can be split. Now this gave knowledge to them. Okay, and enduring concepts: the idea that elements are defined by unique items and the compound and that compounds form from specific item combination like in water is still central to chemistry. Okay, now it gives an idea of chemistry. Now this was how Dalton's model looked. Now sorry, sphere model or ball model, you can say this. It's proposed by John Dalton. Now J.J. Thomson, British physicist. Now this is how he look. Okay, now the second idea was given by the second idea was given by J.J. Thomson. Now plum pudding model in 1904, like exactly after 101 years, he came up with this idea. Okay, he showed another theory. Okay, what he showed. Jason Thomson's atomic model or the plum pudding model, proposed around 1904 after his discovery of the electron, described the item as a uniform positively charged sphere, the pudding with negatively charged electrons, the plums. Okay, so he explained that the pudding is with the positive charged items and plums is with the negatively charged items, and he showed about the nucleus of an atom, and he told that there's something that is called electrons. So he was the one to discover all the things about electrons and described the atom as uniform and positively charged sphere and the negatively charged electrons embedded within it, like the seeds in a watermelon or plums in a pudding. This model explained atoms' electrical neutrality, like equal positive and negative charges. Now, this came as know that an atom is like an atom is neutrally charged, but failed to account for the nucleus or the scattering of alpha particles. Later, disproven by the Rutherford's experiments. So but he also counted to fail about the nucleus of scattering of alpha particles, which was he later was disproven by Rutherford about this opinion. Now, key postulates. Now, positive sphere, the atom is a sphere of uniformly distributed positive charges, embedded electrons, negatively charged electrons are scattered within his, and this positive sphere electrically neutrality. The total negative charge of the electrons equal the total positive charge, making the atom neutral. So these were all the key postulates of his model. Now, analogy: plum pudding or watermelon. The red part or plum is the positive charge, and the seeds or plums are the electrons. So this is how it was named as plum pudding model. Significance and limitations. Now, significance: it was the first model to suggest internal structure of the item, moving beyond Dalton's indivisible sphere. Now, it was significance because it's the first model to suggest internal structure of an atom, because in John Dalton's model it was just a solid sphere with having nothing inside it, but here he told us there's something called nucleus and what is present in the atom. Moving beyond Dalton's indivisible sphere. Limitations: it couldn't explain atomic stability, the existence of a nucleus, or why alpha particles scattered in Rutherford's experiments, leading to its replacements. Okay, now this is J. Thomson's atomic model. You can see here like spherical cloud of positive charges are here and the negative charges electrons. So this was what he thought this is going to be looking like. Now, Ernest Rutherford nuclear model, he or nucleus you can say, he started in 1911, gave it his model at 1911. Now, Ernest Rutherford atomic model 1911 in 1911 proposed the atom has a tiny, dense, positively charged nucleus at its center, containing most of the atom's mass, with light, negatively charged electrons orbiting it, much like planets around the sun. He said that this is just like a solar system, like planets are revolving around the sun, like this. The sun is the nucleus, and the orbits or all the solar system, like all the planets that are revolving around it, are the electrons, like this. Now, this model developed from the gold foil experiment replaced J. Thomson's plum pudding model by showing items were mostly empty spaces with concentrated positive charge and mass, but it could not explain electron stability still. Now, key features of the model: now, central nucleus, a very small, dense core containing positive charge and almost this atom's uh, mass. Electrons or charged particles orbiting the nucleus at high speeds in large empty space. Empty space, most of the atom's volume is empty, allowing most alpha particles to pass through. In the experiment, planetary analogy, often called a planetary model, because electrons orbit the nucleus like planets orbit the sun, like that. Discovery: now, gold foil experiment. Now, alpha particles positive were fired at a thin gold foil. Most particles passed straight through, confirming empty spaces, and a few were deflected at large angles or bounced back, indicating a dense positive center. Now, limitations. Now, classical physics predicted orbiting electrons should continuously lose energy and spiral into the nucleus, but atoms are stable. It did not explain why electrons stayed in specific orbits or the distribution of electrons. Okay, now Rutherford's atomic model, this was how it looks. Now, electrical or electron orbit, and nucleus, and proton, neutron, electron, this was all proven. Like, this was all what he showed. Okay, now Niels Bohr, planetary or energy levels. Okay, now 19 of 13. Now, Niels Bohr's atomic model 19 of 13 proposed electrons orbit a central nucleus is in fixed, quantized energy level shells like planets, rather than spiraling in a classical physics suggested. Explaining atom stability and spectral lines, electrons jump between these shells by absorbing or emitting specific energy photons, with shells closer to the nucleus having lower energy. It's a crucial step between classical and quantum models, explaining hydrogen well, but later superseded for complex atoms. Okay, now key postulates of Borel model of fixed orbit shells. Electrons move in specific circular paths, orbital shells around the nucleus, each with a defined quantity, quantum energy levels. These shells like K, L, M, N, and furthermore have discrete energy values. Electrons in the outer shell have more energy. No energy loose in orbit. No electrons do not radiate any energy while in the stable orbit. No energy transition. Electrons absorb energy, for example, from light to jump to higher shells, excited state, and emit energy light to fall to lower shells, ground state. Okay? Quantized angular momentum only absorb orbits with specific angular momentum values are allowed, leading to quantization. Okay, now significance and limitations. Now explains hydrogen or successfully explained the discrete emission spectrum of the hydrogen atom. Introduced quantum ideas. Now first model to blend classical physics with early quantum theory, incorporating quantized energy levels. Now solar system analogy. Now visualized the atom like a mini solar system, nucleus as sun, electrons as planets. Now limited accuracy. Now fields for atoms with more than one electron, multi-electron items, and doesn't explain fine spectral details or electron probability clouds. Now Bohr's model of an atom. Now he showed K, L, M, N shell and positively charged nucleus. This was what he showed. Now Erwin Schrödinger he came up with a quantum cloud model in 1926. So Erwin Schrödinger's atomic model, also known as quantum mechanical model or electron cloud model, describes electrons not as the particles in fixed orbits like Bohr's model, but as waves occupying three-dimensional regions called orbitals, where their position is only probable. It uses the Schrödinger wave equation to define these orbitals as zones of high electron probability, electron density, replacing defined paths with fuzzy cloud-like shapes where the density indicates the likelihood of finding an electron. Now, key concepts of Schrödinger's model. Now, electronic waves. Electrons behave as waves, not just particles existing as standing waves around the nucleus. Now, wave function, a mathematical solution to the Schrödinger equation that describes the quantum state of an electron. Orbitals, regions of space where there is high probability, around 90% of finding an electron, defined by the solution of the wave equation. Now, how it different from Bohr's model? Now, how it's different from the Bohr's model? Bohr was like electron in fixed planetary like orbits, and Schrödinger studied electrons in probabilistic orbitals like electronic clouds. Ticket significance forms the foundation of the modern understanding of atomic structure, explains electron behavior through wave particles duality, acknowledging electrons as both waves and particles. Now, timeline of key scientists and models. So, first of all, we're having Democritus from 400 BC's. Proposed matter is made up of indivisible particle called atoms, uncountable. And John Dalton, 1803. Now, Democritus, he told us about atoms. Now, John Dalton in 1803, first modern theory, atoms as solid indivisible spheres, element combined in whole number ratios. And J.J. Thomson, 1997, discovered the electron, proposed the plum pudding model, negative charge electrons in positive pudding. Ernest Rutherford, 1911, gold foil experiment led to the nuclear model, dense positive nucleus with orbiting electrons. Niels Bohr, 1913, planetary model, electrons orbit in a nucleus in specific quantized energy levels, shells. Erwin Schrödinger, 1926, quantum model, electrons exist in probability clouds, orbitals around the nucleus, not fixed orbits. Now, Jem Cadbush in 1932 discovered the neutron, completing the understanding of protons, neutrons, electrons in the protons, neutrons, and electrons in the nucleus. Evolution of understanding the progression shows a shift from atoms as solids, fundamental bytes Dalton, to a complex system of subatomic particles, electrons, neutrons, and energy levels, culminating in the modern quantum mechanical view of electrons in probabilistic clouds orbitals. So, thank you everyone. I'll be back with another video regarding any other topic, and different subject, or maybe the same subject. So thank you so much for listening to me, and I hope you understand the structure of an atom very carefully and clearly, and what is an atom, what is the structure of it, what the scientists that came across it. So this is for now. I'll come back. Happy New Year. Allah Hafiz, everyone.